Hi. So in the last video that I made, we went through how to design an activity with a linear equation where students are given what the equation is. Then they need to, over here, sketch their best attempt and most accurate attempt at graphing that equation. So they go down to -3, they go up 1/4, and possibly continuing that even further, drawing what that line's going to look like. Then they should hit finished. And then going over here, they can check how did they do, seeing how accurate their line was. And you can see that I was quite accurate there. But if you're really far off, then you'll really see it. So basically that same stuff needs to happen over here with quadratic equation, except of course when this part can be the same, but when we go over to here, we want to make sure that it's not graphing that same linear equation again. So I'm going to show you some tricks to doing that. So we're going to start with slide 5, which is essentially the same as slide 3. So going back to slide 2, grabbing the CL from here so that we're saving some time, copying it. That one used button 2, just keep that in mind. So going back over here, changing this over to graph. And let's see, I don't have labels on this. So sketch 5, directions 5, and button 5. So we want to change it to button 5 when we put this into the sketch. And there. This slide is all done. Now over on slide 6, it's going to take a little bit of, fussing around with, but it's very similar to slide 3. So I'm going to go into the CL here. I'm going to grab everything that's here, and I'm going to bring it over to slide 6. Directions 6. Graph 6. And button 6. All right, so it's all labeled. Bring it here, paste it. This is going to be button 6, and this is going to be this sketch that we just did, which would be sketch 5. And everything in there should be all set. So if I go into the edit graph, nothing's in there. So there's no way for when we ask if the student presses the button, how'd I do? There's no way for a parabola just to show up. So we have to put that content in here. But otherwise, it's all set to go. So for instance, this allows students to sketch whatever their sketch is going to be for the parabola. Again, not an accurate parabola. They can hit finished and it'll lock this up. So that's working. And then going over here, they can press how'd I do, but it's not going to do anything yet. We're ready for that, but we're not quite there yet. Let's go into the graph and do some editing here. We're going to need 2 different things in here. We're going to need animation, and that's going to be the same as before. And we're going to need a function. Let's actually do this. Let's close out of this. And because the animation is the same as on slide 3, I'm just going to help save a little bit of time here. If you go down to the bottom of the graph in Desmos, you can click on Edit the Graph. It'll bring it into their graphing calculator. And if you copy the link and bring it back into any graph, but in particular slide 6 graph, and you're just going to paste it on the very first line. Paste. And that's exactly the linear graph that we grabbed from, I think it was slide 3. So the animation from before is going to be exactly the same here. So that's perfect. We can leave that. Function's definitely going to change. The function last time was linear, and we're going to want to change that. So let's see. This one, we had the quantity x plus 1 squared, and then -3. Let's see if I can remember that. Oops, wrong spot. I think it was x minus 1 squared. I don't remember. let's see, x plus 1, and then x minus 3. All right, x plus 1, x plus 1, and then here it's minus 3. All right, so this is going to graph the proper quadratic, but just like last time, we're going to need some bounds. So let's use that negative 10 to positive 10. And now you can see what that looks like. It's showing a lot more than we really need for the graph for this activity, because the y-axis only goes from negative 10 to positive 10 as well. So this is a little bit overdone, but it'll still do the job. You could adjust it a little bit so that, you know, maybe you have an x of negative 6 or something, unless you want to figure out exactly, you know, negative 5 or... no, we would want bigger than, yeah, we would want it to be at least here, the very least, negative 4.6, and then at least don't stop before like a 2.6. So, but I'm just going to leave it at this. And let's put the animation on this one. And we can see that that's not far enough because it's just regular 10. So let's make that negative 10. Plus 20a. All right, so what that does is it just allows us to go from a sub 1 of 0 will give a negative 10, and a sub 1 of 1 will go to positive 10 overall, just like last time. We can test it out within the graph. Just move that timer, and you can see that quadratic graphing. So you could adjust it a little bit more if you wanted to, but this will work. Slide 5. We're going to go to, if we had our original parabola and we shifted it, we could do that. We're going to have a parabola that we're going to end up drawing. Again, I just did a quick one, but how'd I do? And this time we can see that we were way off. So your students will see that too if you use this activity. The next one that I wanted to show you is a trig wave, and rather than go through the entire thing in a video because it's pretty extensive, I wanted to just sort of quickly explain it. Everything that's needed to be there is there. And so in this example, it was quite a bit more difficult. I had to put in my own numbers on the axes because it doesn't just label in radians automatically. I needed to do quite a bit around the labeling, and then I also had to do a bit around getting it to graph properly. So let me just really quickly run through some of that. So I had to do the labels, the forced labels within the sketch, and then also on the graph on the next slide. The labels are the same. So the forced labels, I looked at an activity that Jay at Desmos had put together and sort of broke it down and understood how he did it. He used lists, like this is a list right here. And then also he used parametric to graph these lines in various places, the little tick marks and such. So if you're not fresh on parametrics like I'm not, I had to go back and sort of like remember how this is done. So, and then using labels in certain places, you know, to label what you want. This is a bit more advanced in terms of graphing, depending on where you're at. So if you're a beginner on graphing, this is pretty intense right here. I wouldn't start with something like this. And then in slide 9, so the CL, I should go back. Slide 8 CL, pretty much exactly the same. This, I did need to account for it being in radians. So, I'm not using the standard zoom that I used in the last ones of -10 to +10 on both X and Y axis. I had to adjust it for the radian measure. But other than that, pretty much the same, just adjusting for button 8. And then on slide 9, again, there's that radian measure for the bounds. This looks the same as before. That looks the same as before, just changing it to button 9 and sketch 8. So again, just making that really fast with those variables. And then the graph is a bit different. So in the graph, I just wrote down what the function was without any special stuff. And then I had to kind of figure out what are the restrictions going to look like. And again, that is based off of it being in radian measure, needing to sort of figure out, how do I get from here to here? But it's the same concept as the -10 to +10 type of restriction. And then the animation's the same. The only added thing in here are those forced labels that I showed you in the other one. That creates the X and Y axis. It creates each of the tick marks along here. It creates the labels on them. So that's all put together. So this one, if we go to slide 8, we can preview. This one asks the student to draw their sine wave here. And I'm not going to draw it accurately, but, something like this. They're going to finish. They're going to go to the next page, check how they do, and they can see if they're accurate or not.